Good afternoon, class. In today's notes, we're going to talk about the quadratic formula. The quadratic formula is shown here. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the quadratic formula is used to solve quadratic equations. Now, in class, up until now, we've been solving quadratic equations by factoring, but the quadratic formula will come in play when we have quadratic equations that we cannot factor. Before we jump into and start solving quadratic equations using this formula, I'm going to take today's notes and we're going to talk about this value underneath the radical here. The value that I drew a circle around here, that b squared minus 4ac, we call that the discriminant, and we're going to talk about the discriminant in today's notes. Okay, so the value of the discriminant will tell us the number and types of roots a solution of a quadratic equation has. So again, remember, we call these x-intercepts roots and solutions, and the purpose of the discriminant is to help us know what our answer should be based on its value. Okay, so I made this little table here where we have the value of the discriminant, the number and type of solutions, and the x-intercepts. So the first value I'm going to look at is for when the discriminant is greater than 0, and what that tells us. Okay, so if the value of the discriminant is greater than 0, I'm going to have two real solutions. And we distinguish between the real, we say real rational or real irrational. If I have a real solution, it will be a rational or real rational. If the value of the discriminant is a perfect square, and it will be a real irrational if the value is not a perfect square. Okay, and what this means for the x-intercepts is that I'm going to have two intersects on the x-axis. It is actually going to cross the x-axis two different ways. And these are two separate graphs. They have nothing in common. I just want to show that a positive and a negative quadratic. But when I have a discriminant value greater than 0, I'm going to have two x-intercepts on the x-axis. Okay, the next value we're going to look at is if the discriminant happens to equal 0, what does that tell us about the graph? So if I have a discriminant equal to 0, I'm going to have one real solution, and it will be a rational number. And if you can remember back to your middle school and elementary school days, rational numbers are anything that can be written as a fraction. It will not have anything left under the quadratic sign. I'm sorry, under the radical sign. And what this means for the x-intercepts is that I am going to have one intercept. It's going to actually touch at one point and then change direction. So your vertex is the x-intercept, and there's only one of them. And the last value of the discriminant would be if the value of the discriminant was less than 0. And if that was the case, I'm going to have two imaginary solutions here for this example. And what my imaginary solutions will look like on the x and the graphs is they will just kind of be out here floating in space, and they're not going to cross the x-axis. That's why we have imaginary solutions, because they do not cross the x-axis. Alright, so let's work some examples. So in the examples I want to find the discriminant of each equation, then state the number and type of solutions. So my first equation here is 3m squared minus 3m plus 6. So I am in standard form. I've set equal to 0 so I can go on. So the first thing we always want to do is identify your a, b, and c value. So my a is 3, my b is minus 3, and my c is positive 6. Alright, so we're going to plug that into the b squared minus 4ac and solve. So we have negative 3 squared minus 4 times 3 times positive 6. Negative 3 squared is positive 9. I need a negative there. Sorry, the negative b is negative. So negative 4 times negative 3 is positive 12. Plus times 6 would be positive 72. And then I add these together and I get 81. So my discriminant value is 81. So if I remember from my notes that if I have a discriminant greater than 0, I have two real solutions, and these are going to be rational solutions because 81 is a perfect square. Okay, my second example, I'm going to do the same thing. I know it's in standard form. I've identified my a, b, and c values, so I can plug it into the formula b squared minus 4ac. So I have b squared is minus 8 squared minus 4 times 8 times 2. So I wind up with negative 8 squared is positive 64. Minus 4 times 8 is 32 times 2 is 64, so that is 0. So I remember from my notes that if it's equal to 0, I have one real solution. In my third example, I have 5x squared minus 6x equals 2. So before I start anything, I have to get this in standard form. So to do that, I'm going to subtract 2 from both sides, and I wind up with 5x squared minus 6x minus 2 equals 0. So we're going to go ahead and identify our a, our b, and our c. Our a is positive 5, negative 6 is our b, and negative 2 is our c. So then we have b squared minus 4ac. We'll multiply negative 6 squared minus 4 times positive 5 times negative 2. So negative 6 squared is 36. And negative 5 and 4 is negative 20 times negative 2 gives me positive 40. And that is 76. So again, I wind up with a greater than 0 value. So I know I have two real solutions, and this is going to be irrational because I know 76 is not a perfect square. Okay, our fourth example here is 3a squared plus a plus 2 equals 0. Standard form. I've identified my a, b, and c. Plug it into the value for the discriminant, so I have b squared would be 1 squared minus 4 times 3 times 2. I get 1 minus 4 times 3 is 12 times 2 is 24, and I wind up with minus 23. So now I have a discriminant value less than 0, so that tells me I have two imaginary solutions. Okay, that's it for today's notes. Make sure you bring these with you to class. Make sure you complete the submission ticket after the video. And have a good night, and I will see you tomorrow. Bye.